Today, guys, we're continuing with 7-6, dealing with rational exponents. Does anybody know how to rewrite the number 81 with 3 to a certain power? 3 to the power of what would equal an 81? 3 to the first is what? 3. 3 squared is 9. 3 cubed, 27. 3 to the 4th is 81. So what I want you guys to do on your paper, instead of the number 81, I want you to write it as 3 to the 4th. So this number right here, 81, can also be rewritten as 3 to the power of 4. Now, 3 to the power of 4 is raised to the exponent of a 1/4. Does anybody know what property this property is called? Well, no. 1/4 is the inverse of 4. You're right. That is true. But this is actually called the power of a power. Whenever you have a power and you have another power right there, you're allowed to do what with those exponents? You're allowed to multiply. So what I want you guys to do is I want you guys to multiply the number 4 times 1/4. And that becomes 4 over 4. And what is 4 divided by 4? 1. 1. So it becomes 3 to the first. Well, 3 to the first is just simply the number 3. So 81 to the power of 1/4 simplifies just to the number 3. Now, we've been mainly dealing with positive exponents. But we can also use the same properties when you're dealing with negative exponents. So I want you to continue a pattern for me right here. We're going to stop at 3 to the negative third. 3 to the power of negative 1 is going to be 1 over 3 to the first, which equals 1/3. 3 to the power of negative 2 is going to be 1 over 3 squared, which becomes 1 over 9. 3 to the negative third is going to become 1 over what? 3 to the third, which is 1 over 27. So understand, positive exponents, see right here we got a 3, we got a 9, we got a 27. 3 to the negative third is simply 1 over 27. Okay? So you might want to write that pattern down in case you get yourself involved in a negative exponent, you know what to do with it. Okay? So here's the concept for negative exponents. You could write down, ready? A to the power of negative n will always equal 1 over a, whatever that number is. This is something you can have in your journal to help you be able to convert things from negative exponents to positive exponents. All right, we're going to go ahead and move on to number 10. Right now, what I'd like you to do is I'd like you to write number 1024. I want you to look at your little table that we created and think, is there another number raised to a certain power that equals the number 1024? What is it? That's right, the 4 to the power of 5. These mean the exact same thing. Remember that table we made in your journal? This is where you're going to use that table to help you guys. So we have 4 to the 5th is equal to raised to the power of negative 1/5. What property is this called right here? When you have a power and a power, it's called power of a power. Whoa. What are you allowed to do with those? Multiply. Multiply. So let's multiply. We get 4 to the power of negative 5 over. What does that become? It becomes a negative 1. Well, wait a second. What is 4 to the negative 1 actually equal to? Yes, 1 over 4. That is correct. It is equal to 1 over 4. So what Raymond just did there is he just applied the concept we just did with 3's, he applied it to 4. So in case you didn't catch why that is the way it is, 4 to the 0 is 1. And by the way, any number to the 0 power is 1. Okay? What's 4 to the first, everybody? 4. What's 4 squared? 16. Now, Raymond says 4 to the negative 1 was what? 1 over 4. 4 to the negative 2 would be 1 over 4 squared. But what does 1 over 4 squared equal? 1 over 16. So right here, this is why 4 to the negative 1 is equal to 1 over 4. Okay? Negative exponents just are really, really, really small numbers. They're fractions. The reason we're doing this right now is because we are trying to do all of these without the use of a calculator. We're showing all of our work. So yes, you could technically type certain things in the calculator and press enter and you get the answer. But we're doing this without a calculator because there are questions that you're expected to do without a calculator. Here we go. Number 11. Write negative. Open up a parentheses and we're going to change the number 256 to a different number. 256. 256 equal. Heck yeah, but 4 to the power of 4, and understand that the number 256 is the same as equivalent to 4 to the 4th power. This seems a little redundant. Well, what am I allowed to do with those? Multiply them together. So here we go. We've got a negative. Right here, inside the parentheses, we're going to go 4 to the power. What is 4 times negative 3?
Negative 12.
Negative 12. Very good. Negative 12 divided by a 4.
Negative 3.
Ooh. Interestingly enough, Zach, we get a negative 4 to the negative 3rd. By the way, Zach, what is 4 to the negative 3rd actually equal to? 1. 1 over 4 to the 3rd. But wait, we can go further.
It's 1 over 60.
That's the last. Right here. So if we have a negative 1 over 64, then our final answer is literally negative 164. Did we do it? Did we use the calculator at all for this? No. No, we did not. However, if we were to use the calculator, you could type in, I'm going to clear, not graph anything, so second, quit, clear everything out. I'm going to go negative 256. I'm going to raise that sucker with the power of negative 3 divided by 4 and press enter. And you get that. And then you hit the math button and press enter twice. And you get what? Negative 1 over 64. But you guys realize that there are tests out there where you're not allowed to use a calculator. Okay? So you can use the calculator to check your work, but you can't use the calculator to do your work. You have to show all your work. Here we go. Now, this is the last one we're going to do right now. We've got a negative 64 raised to the power of negative 2/3, and I need to change this negative 64. I've got to change that number to a different base. So instead of 64, we could do 8 squared, right?
Yep. 4 to the
8 squared is 64. What else? 4 to the 3rd is 64. By the way, my suggestion is to use this one. The reason why I want to use this one is what's my exponent here?
3.
What's my denominator here?
3.
That's going to help us simplify. All right? So let me explain why we're going to do this. We're going to put 4 to the 3rd right here. We're going to do a power of a power. And we're going to get negative 4 to the what? Negative 6 over 3. Now, is 6 divisible by 3? It is. What is it? Which equals a 1 over a what? Negative 4, right, which is being squared. So yes, your final answer is what? 1/16, because a negative times a negative ends up becoming a positive. Now let me explain to you real quick why we did not use 8 squared. Hopefully you guys will understand. I'm going to use 8 squared and show you why we didn't want to use it. So check this out. If I change this to a negative 8 squared and I raise that to negative 2/3, that would give me a negative 8 to the negative 4/3. Do you see how if I multiply, I can't really simplify. Can't simplify that, okay? So what did I have to change this to? I had to change it to 4⁵ for that to work. Now if you got stuck here, here's what you could do. You could change the negative 8 right here. So negative 8, you could put 2 to the power of 3, and then raise that to the negative. Yeah, then it would work. Yeah. But before it wouldn't. Like this doesn't work, this does. Because, will the 3's cancel out right here? They will. Alright. So, what I'd like you guys to see the difference, this is the last thing I'm going to show you right here. I want you to see the difference between if I said, see where the negative is? Where is it? It's inside the parentheses. So check this out. If I said negative 64 raised to the power of, was it 2/3 or negative 2/3? Negative 2/3? Okay. Hit the math button. Math button, press it twice. That becomes negative 160. Well, watch what happens if I open up the parentheses and type in negative 64. Close the parentheses. Raise it to what? Negative 2 divided by 3. Look what your final answer will be. Positive. So if the negative is on the inside, this becomes a positive. Yeah. But if the negative is on the outside, when we go up here, look at the negative. You see, these right here, everybody. This problem right here is different than this problem. So yes, parentheses do matter. Okay, parentheses matter. Why don't you tackle number 14 on your own? All right, you guys tackled number 14. What did you guys get to replace the number 64? What'd you put?
4
to the 3rd. So we have 4 to the 3rd raised to the 2/3. All right, how about the denominator? What did you guys put for 343? 7 to the 3rd. I like it. Now, we have a power of a power. What does that become? What is 4 raised to the power of what? You're right, it is to the power of 2. But before I did that, what's 3 times 2? We get what? 6. And 6 divided by 3 is 2, which becomes the number 16. Same thing happens with the 7. 7 to the power of 6/3. 6/3 simplifies to 7 squared, and 7 squared is a 49. So your final answer is 16 over 49. They have no common factors. This is a whole bunch of 2's. This is 2 to the 4th, or 4 squared. This is a whole bunch of 7. This is 7 squared. These cannot be simplified. All right, you can still do this without real numbers, like we're talking about. You can use variables. What kind of property is being dealt with right here? Multiplication, power of a power. So this is just u. What's a negative times a negative? Positive. What's 1 times 4? 4. What's 3 times 5?
15.
You're done.
Whoa, dude.
It's not that hard. Wait. Number 16. This is not the power of a power property. This is called the product property. What are we allowed to do with these exponents? Add them together. What is this going to give us? It's going to give us s to the power of 16 over 4. But what is 16 divided by 4? 4. Boom, you're done. So you need to know when to add and when to what? And when to multiply. When to add, when to multiply. Have a good day.